Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Easy Peasy Sudoku Advent 17, and it's actually a sum and product killer by Richard. And here are the rules. We have apply classic Sudoku rules, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. A small number in the upper left corner of each cage, which is a dotted outline region, indicates the sum of the digits in that cage. Now, this is actually not this is not correct. This is actually not what it means. And the reason why is it'll show in the next rule. An X between cells indicates that the two adjacent digits are multiplied when calculating the cage total. For example, 14 can be formed by the digits. So assume this was a 14 in the upper left-hand corner here. You could have 4 times 3 plus 2 to add up to 14. Or you could have something like 9 times 1 plus 5, which adds up to 14 also. Because 4 times 3 is 12 plus 2 is 14. 9 times 1 is 9 plus 5 is 14. So the way I would put this rule set is basically the number in the top left corner of the cage is the sum of all the products in the cage plus any additional digits which are not part of any product. So, for example, in this 15 cage, this is a product because you multiply two digits together. This is a product because you multiply two digits together. You sum those products together, right? You multiply these, you get a product. You multiply these, you get a product. You sum those products, and then you sum any additional digits that are not part of a product in the cage. So that's how you would get 15. And within each cage, all digits must be different. So you cannot have repeats of digits in cages. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. I think the ones that are the easiest to... Okay, so these digits, can you ever have 2 times 3 here? I think the answer to that is no. Well, okay, can you ever have a non-1 as part of these? And the answer is no. Right? Because if you don't have a 1 here, the minimum to multiply together is 2 times 3, which is 6, which is greater than what this cage can sum to. So we're guaranteed 1 here. 1 times 4 doesn't work because it would add up with 1 to add up to 5. So this must be 1 times 2 times 3, and then we have 2 and 3 here. That means, so we're guaranteed a 1 here. Similarly, where can you have this multiplied by 1, or non-1 here? No, because that would be 2 times 3 plus 1 at minimum, which adds up to 7 at minimum. So there has to be a 1 here. It cannot be here. It has to be here. So you have a 1 here. And I think this has to be 2 times 4, right? It's basically, yeah, it has to add up to 6. You can't have 1, 5. These two digits, since this is times 1, it's essentially the same as these two digits must add up to 6. So this has to be 2, 4 as a pair, which eliminates 2 and 4 in the rest of the row. So this can't be 2 or 4. It's 1, 3 times 1 times 3, which is 3, plus 2, which adds up to 5. That means the remaining digits in the row have to be 5 through 9. Okay. This product must add up with another digit to add up to 48. A digit can only be 3 through 9 here. If you have 9, that's 39, but that's not going to be divisible, but that's not going to be, cannot be a product of 2 digits, so that doesn't work. 48 minus 8 is 40, which could be 5 times 8, but then you'd have a repeat in the cage, so this cannot be 8. 48 minus 7 is 41, which is a prime number, so that doesn't work. 48 minus 6 is 42, but that can only be multiplied by 6 and 7, so that would be a repeat in that cage, so that's not allowed. 48 minus 5 is 43, which is a prime number, so that's not allowed. 48 minus 4 is 44, but that's not the product of 2 digits, so this can't be 4, therefore this must be 3, which 48 minus 3 is 45, which is essentially 5 times 9. That eliminates 5 and 9 in the rest of the row because of the 5-9 pair. So we can do something similar here, right? What about this? This cannot contain... Let's just continue with the ones in that we have very restricted. So this has to be 4 through 9 here in this box. This is... Okay. 26 minus 9 is 17, which is prime, so that doesn't work. 26 minus 8 is 18, which could be 3 or 6 or 2 or 9, but we don't have 2 or 3 available, so this doesn't work. 26 minus 7 is 19, which is prime, which doesn't work. 26 minus 6 works if this is 4 and 5, so that works. 26 minus 5 is 21, which is 3 times 7, but we don't have access to a 3 in the box, so that doesn't work. And 26 minus 4 is 22, which is 2 times 11, which are not 11's not a digit. So this must be 6 with 4 and 5 to add up to 26. That eliminates 4 and 5 in the rest of the box. This can't be 5 then. So this is 9, which eliminates 9 here, so that's 5. That means the remaining digits in this upper left-hand box are 7 and 8. Okay, so this is 7 or 8. It has to be multiplied by 1. If it's multiplied by anything else, it's going to be too big for the sum. So this must be 1 here. If it's 8 and 1, they would have to add up with 1, so that doesn't work. So this must be 7 times 1 plus 2 to add up to 9. 7 eliminates 7 here. This is 8. 26 minus 8 is 18, and you cannot have 2, 9 because of 2 in the box, so this has to be 3 times 6. 6 can't be here because of 6 in the column, so this is 3. This is 6. 3 eliminates 3 here, so it's 1 and 3. So that's done. That's 3 in the corner. We celebrate because we're nowhere close to... Well, we're close to something. I'm not sure what. Where are 2 and 4 in this central, this top central box? They cannot be here because of a 2, 4, 5 triplet in the row. It can't be here because of 2, 4 pair in the row. This is 1, so this has to be a 2, 4 pair here. Remaining digits here have to be 6, 7, 8, or 9 in this upper central box. Remaining digits in row 3 have to be 3, 5, or 9. Well, what are the only pair of digits that multiply to a sum that's less than 21? 3 and 9 already multiply to 27, so that doesn't work. And 5 and 9 multiply to 45, so that doesn't work. So this must be 3 and 5, which adds up, which multiplies to 15. 15 plus 6 adds up to 21. So this is 6, which eliminates 6 here. This can't be 3 or 5. This is 9. This cannot be 6. So this has to be 7, 8, and 9, and this is 7 or 8 there. Okay. One of these is going to have to What's the minimum amount for two multiplications together? If you tried 1 and 2 multiplied and 3 and 4 multiplied, that just doesn't work. Well, this can't be 2 or 3 anyways. This is at minimum 1 and 4, which is multiplies to 4. This is at minimum 2 and 3, which multiplies to 6, which adds up to 10. So this is the minimum for each, therefore they must be exactly what it's needed. So this has to be 1 and 4, because it can't be 1 here. This can't be 3, so this is 2 and 3 to add up to 10. That means the remaining digits in the box are 5 through 9. This can't be 5. Remaining digits in column 4 are 6, 7, 8, 9. This can't be 6. Remaining digits in row 4 are 5, 7, 8, 9. Okay. Can this ever be 4 times something? Well, the somethings are 5, 7, 8, 9. 4 times 2, 5 at minimum is 20. 20 plus 2 plus 5, or plus 7, actually, I guess it would have to be, would be way too big than 22. So this can never be 4. This is 2. This is 4 then. So 22 minus 4. This must be an even digit. To add up to 22, you have even digit, so even sum, even sum. Even digit, even sum. This must therefore be an even digit. So this is 8 because the only even digit left. So we have 4 plus 8 is 12. 22 minus 12 is 10. And that's 2 times 5 then. So this cannot be 5 in the rest of the box and row. This is 7, 9 as a pair. 9 eliminates 9 here. So this is 7, which makes this 9. What multiplications here work to add up to 50? 6 and 7 obviously do. 42 plus 8 is 50. 6 and 8 does not, though. That's already too big. 48 plus 7 at least is 55, which is too big. And then 7, 8 doesn't work. It's basically, so this has to be 6, 7. 6 times 7 plus 8. Which means this is 8, this is 9. That eliminates 9 from the rest of the column. This cannot be 9 times 2 or 3. If we try to have something besides 1, it would have to be at minimum 4. 4 times 9 is 36, which is way too big to add up to 23. So this has to be 1 times 9. So we have, essentially, these are added together, these digits. So it must be 6, 8, and 9, and this can't be 6 or 9. So this is 8. This can't be 7 or 8. This is 6. Therefore, 1 times 9 is 9, plus 8 plus 6 is 23. So this cannot be 6 here. 6 and 7 eliminates 6 and 7 in the rest of the column. So this can't be 6 or 7. It's 8. This can't be 7 or 8. It's 9. 8 eliminates 8 here, so it's 7, which makes this 8. This 7, 8 eliminates 7, 8 here, so it's 6. This can't be 8 or 9. It's 7. So remaining digits in column 6 are 1, 3, and 4. I think this has to be a 1 here. If you have 3 and 4, that's 12. This is at minimum 2 times 3, which is 6. So 12 plus 6 already is 18. So this has to have a 1. This can never be 3 times 4 because that would eliminate 3 and 4 as possibilities here. And we know there's a 3, 4 here. Let's just continue. What are the remaining digits in column 3? We have 3, 4, 5, and 6 possible. This can't be 6. This digit cannot be 1, 3, or 6, so this could be 2, 4, 5, 7, 8, 9. 23 minus 2 is 21, but that would be 3 times 7, but we can't have a 7 in the multiplication here, so this can't be 2. 23 minus 4 is 19, which is prime, so that doesn't work. 23 minus 5 is 18, so this could be 5 and 3, 6. That is possible. So 5 is a possibility. 23 minus 7 is 16, which would be 2 times 8 or 4 times 4. 4 times 4 obviously doesn't work. And 2 times 8 can't work because we have a 2 and 8 in that column. So this cannot be 7. 23 minus 8 is 15, I believe. Yes, and that's 3 times 5. So we have 23 minus 5 is 18. That's 3 times 6. 23 minus 8, which is 3 times 5. So we're guaranteed a 3 here so far. And 23 minus 9 is 14, which can only be 2 times 7, but that's not possible. So this can't be 9. So we're guaranteed a 3 here, so this can't be 3. We are also guaranteed one of these is 5, because this is either 5 plus 3 times 6, or 8 plus 3 times 5. So 5 has to be one of these digits, which means eliminates 5 in the rest of the box. What are these possibilities? So again, this can be 2, 4, no 5, because the 5 is eliminated in that box. 7, 8, and 9. And these multiplications can be 1, 4, 5, 7, 9. Okay. 30 minus 2 works. It could be 4, 7. I don't think this can ever be 1. 1 times 9 at most is 9 plus another 8, which is only 17. So this cannot be 1. So 2 works with 4 and 7. Actually, can 9 ever be here? I think the answer is no. 4 times 9 is 36, which is way too large. So that cannot be 9. 4 times 5 doesn't work, because 5 times 7 doesn't work. 4 times 5 doesn't work because that's 20, plus a single digit never adds up to 30. 5 times 7 is 35, which is too large. So this has to be 4, 7, and 2. So that eliminates 4 and 7 in the rest of the box. So this can't be 4. This is 6, so this can't be 6. This has to be a 3, 5 pair to multiply to 15. 15 plus 8 adds up to 23. This 3, 5 pair eliminates 3 and 5 in the rest of the column, so this can't be 5. This is 4, which makes this 5. Remaining digits in this lower left-hand box are 1 and 9. This can't be 1 because of 1 in the column, so this is 9, which makes this 1. That eliminates 1 from being here, so where's the 1 in column 6? It has to be here. Remaining digits in column 5 are 2, 5, and 9. This can't be 9, this can't be 2 because of 9s and 2s in the rows. Remaining digits in column 1 are 5 and 9. This can't be 9 because of 9 in the row, so this is 5, this is 9. Remaining digits in column 2 are 4 and 7. So either of these could be 4 or 7. Okay. Remaining digits in row 6. Actually, let's do 25 here first. This digit cannot be 2, 6, 8, and 9, so it could be 1, 3, 4, 5, or 7. The digits here can be 2, 3, 4, 5, 6, and 8. And this can't be 2 or 6 because of 2 or 6 in the row. So 25 minus 1 is 24, and that works with 3 and 8. or 4 and 6, so that works in multiple ways. 25 minus 3 is 22, which is 2 times 11, which is not a digit, so that doesn't work. 25 minus 4 can be 3 and 7, but you can't have a 7 in the multiplication product here because of 7 in the column. So this doesn't work for 4. 25 minus 5 is 20, which could be 4 and 5, but then you'd have a repeat in the cage. So that doesn't work. And 25 minus 7 is 18, which could be 3 and 6. Okay, so what are the possibilities? This is 1. That's 24. So it could be 3 and 8. Or it could be... oh. Well, where is 8 in column 9? 8 can't be here because of 8's in the boxes. 8 can't be here because of 8 in the row, so you're guaranteed an 8 here. So if this is 1, this is 3 and 8. If this is 7, 8 doesn't multiply to anything that adds up with 7 to add up to 25, right? 25 minus 7 is 18, but that can only be 3 times 6. So this has to be 1 with 3 and 8 here to add up to 25. Where is 1 in column 7 then? Cannot be here because of 1 in the box. Can't be here because 1 in the box. Can't be here because 1 in the row. Can't be here because that's an 8. So this must be 1 there. Remaining digits in row 6 are 2, 3, 4, and 6. They cannot be 7 because of 7 in the box. 2, 3, 4, and 6. This can't be 3 because of 3, 8 pair in the column. What digits can this be? No 1. Could be 2, 3, 4, 5, and 9 as possibilities. No 3 because of a 3, 8 pair in the box. Okay. This can't be 3 times 4. What happens if we don't have a 2 here? Actually, we have to have a 3 here. Because 3 can't be here, 3 can't be here, 3 can't be here. And 3 can't be here because of 3, 8 pair. So this must be 3 here, which eliminates 3 from being here. So this is 4 because there's no repeats in the box. So that means this is not 4. This is 3, which eliminates 3 here. So it's 8, which eliminates 8 here. So it's 3. 8 eliminates 8 here. So it's 7 and 8. 7 eliminates 7 here. So it's 4 and 7. 3 eliminates 3 here. So it's 5 and 3. 5 eliminates 5 here. So that's 2. So this cannot be 2 here. 4 eliminates 4 in the rest of the cage. So if this is 3 times 6, it would be 18, which is already too big. So this cannot be 3 times 6, it's 2 times 3. That eliminates 2 and 3 in the rest of the cage and the box, or the row, and box. This 2, 3 pair multiplies to 6 plus 4 is 10 plus 5 adds up to 15. So this is 5, which eliminates 5 here, so it's 9 and 5. That leaves this as a 9. This 5 eliminates 5 here, so it's 3 and 5. 3 eliminates 3 here, so it's 2 and 3. Remaining digits in row 7 are 2 and 7. This can't be 7 because of 7 in the row or the column. So this is 2. This is 7. 2 eliminates 2 here. So this is 4 and 2. 4 eliminates 4 here. So it's 6. 6 eliminates 6 here. 7, 6. 7 eliminates 7 here. 4 and 7. And the rest we do by Sudoku. This can't be 4. So this is 5, which makes this 4. That leaves this digit as a 6 and this digit as a 4. And that's a solution. I could see this actually being, yeah, I think these are all easier puzzles than the ones that I think Richard came up with previous. So I could see this actually being pretty a pretty interesting way of restricting things. It's not overly restrict. It doesn't restrict that much, actually, if you think about it. But it restricts a decent amount depending on how you place things, right? So I could see this being very useful as a potential tool to set things, to set puzzles. Anyways, I wanted to try it. I was curious what this rule set was, and I think it's pretty interesting. It's pretty interesting. Well, I hope you had a good time watching this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.